Looking at the most missed questions on the two-dimensional motion test for 2022, I want to look at 3, 5, 13, 18, and 19 as those with the worst performance. Question number 3 is based on a skateboarder trying to skate horizontally off a building and jump over a pool. And this is a horizontal launch, and so I would simply list my DVAT. Because it's both vertical and horizontal, I would list them separately. And in the horizontal direction, in the X direction, I know that I have those backwards. That was 30, and this one was 37. And I know that horizontally, my velocity is always the same because I have 0 horizontal acceleration. I know vertically that I have an acceleration of -10 meters per second squared, and I know that my initial vertical velocity was 0 because it's in free fall, and that's just a horizontal launch. We don't have an initial velocity at any angle, so I don't know anything about my final velocity. I know that I have D, I know I have initial velocity, I know I have an A, and the problem said solve for T, so I'd need a variable with T. I need an equation that has D, V initial, acceleration, and time in it. Which one of these has those 4 features? This one has D, but it has no A. This one has V final. I can't use V final. This one has D, V initial, time, and acceleration. This is the correct answer. This one has V final in it, and this one has no acceleration, so that would not work for me to solve for time, so I can't consider that one. This was a matter of you having worked these problems before and being able to select an equation. This should have been a pretty easy question, so I was a little surprised at its popularity. Just at 50% of you were able to pick the right equation. The next most missed question was number 5. That involves the same situation, and it asks for you to find the initial speed that would be in the X direction, because that's the only speed that he's going to have to barely clear the pool. And since you were unable to decide that that was the equation you needed, shouldn't be too surprised that you were unable to solve for it, but let's solve for the time. So I set up that equation. I know that my vertical distance is 37 meters because this is 37 tall and this is 30 wide. And I know that my initial velocity horizontally is vertically is 0. I know to take 1/2 of -10 times t squared, and I can solve for t and find that to be about 2.7 seconds, which was actually question number 4, and most of you found that one. So why you didn't use that with the information that you were given, what initial speed, that'd be finding my horizontal velocity. And velocity is simply distance divided by time, and my time was 2.7, and my distance horizontally was 30. So 30 divided by 2.7 is a velocity in the X direction of about 11 meters per second. And I accepted, of course, 11.0, 11.029, 11.03, some variation on 11 meters per second. The next question is number 13, and it has a bird flying due west at 1.88 meters per second, and then going north at 4.17. So I need to get my resultant vector here, and I can use 4.17 squared plus 1.88 squared equals my hypotenuse squared, or 4.57 or 4.6 meters per second in that direction. And many of you got partial credit for that part, but what's missing is that this is a vector, has both velocity, which you found, and direction. So you need to find the angle. For that, I would probably use the tangent of theta equals my opposite side, that's the 4.17 side, over the adjacent 1.88, and that gives me a resultant angle of 65.7 degrees. So this is 65.7 degrees. So you could have answered 65.7 degrees north of west. If you had solved it the other way, where you drew the 4.17 vector first and then the 1.88, you could have also answered with the angle with respect to the north, and that would be a certain number of degrees. So what would that be? 90 minus 65.7. You could have answered 24.3 degrees west of north. Either one was acceptable, but most of you did not give any direction at all. The second most missed question was a multiple choice question with graphs. A cannon shoots a cannonball horizontally to the right off the edge of a cliff. Which velocity versus time graph correctly describes the horizontal motion of the ball? Horizontal, that's in the x direction. That's constant. Remember setting up our DVAT table in the skateboard problem? That means that it's always the same. That means that my horizontal velocity is a constant value at all times, so it can't be this one and it can't be that one, because those both show a changing velocity. Is our horizontal in the x direction motion positive or negative? It's moving to the right, which we normally take as positive, so that means our answer choice was C, because D gives us a negative velocity. That would have been moving to the left. And the most missed question on the test is number 19. A ball thrown into the air at some angle. So we're going to have a launch at an angle with a trajectory that looks like this, and we're talking about what's happening to the ball right here in terms of its velocity. V in the x direction, you know, is constant, and you know in the y direction, that's when it doesn't have any. So the velocity at this point is not zero. It's only true for Vy. But Vx is constant. It does not have any vertical velocity. It's entirely horizontal because it has zero vertical velocity. I hope this helps you. I will say that there was a great improvement on this test over the first two, and in just a moment I'm going to go through the most successful questions.